I decided that I would present on a single paper that is hopefully in the last round of reviews and will soon be published. And this is joint work with scholars at the lab and Indiana University. And really what this is actually is a continuation of the topic that I came here to talk to you about last year, and that is the topic of energy poverty and energy insecurity. Now, this refers to when a household struggles to pay their energy bills or to keep the house warm enough or cool enough for them to be comfortable and to survive. Now, when a household cannot or when a household does not have access to electricity or can't afford it, they can't run devices, which means you wouldn't be able to use your computers in here. You wouldn't be able to use your phone to seek information or assistance. You can't run a refrigerator, which means you can't keep perishable and healthy food. Without electricity, you can't run an electronic medical device, which millions of households rely on every day for their livelihoods, for their lives. And you might not be able to keep your body warm or cool, which can lead to a variety of mental and physical health outcomes, including in the very extreme but not at all rare case can lead to death. Now, I'm particularly interested in solutions to energy insecurity and energy poverty within the United States context in particular, and I've been working on several projects thinking about preventative measures for energy insecurity. That is, how do we help households avoid ever entering the state of being insecure or ever becoming disconnected from their service provider? Now, I have a variety of studies. Hopefully one is that I can present next year is on a randomized controlled trial, a field trial that we're implementing with weatherization and electrification in multifamily dwelling units. But the project that I want to focus on for my remaining 3 minutes is on the integration of solar, residential solar. And the question is whether residential solar can help reduce the incidence of energy insecurity. So what we've done essentially is we've taken this fabulous data set of all solar owners across the United States. I'll just go ahead and click so you can see the data here. And we've taken this data set and we've identified all solar owners in the United States that adopted solar in the year 2021. And we have household characteristics for them, socio-demographic characteristics, housing condition characteristics, information about the climate zone and the region. And we've taken all these observable characteristics and essentially we have matched to the best of our ability the solar households with other households that don't have solar but look identical on all observed characteristics. So we've used this matching technique essentially to identify every household that we want to study, and then we sent surveys to all of these households. And in the surveys, we asked questions about their solar panels, whether they had incentives for their solar panels, as well as a suite of questions on energy insecurity. Now, here are the results. We asked several different questions. There's a lot of outcome variables that one could use for energy insecurity. Questions such as, can you pay your energy bill? Have you ever received a notice for disconnection? Do you need to reduce your energy consumption? Do you need to keep your household at an uncomfortable temperature? And do you need to forego other expenses to pay for your energy bills? Now, you can look at the main specification here in black, but then also note that we've run a variety of other specifications, robustness checks, adding in more control variables, pulling out or adding in the pilot responses, recategorizing according to income, looking at just households that align within a county, and dropping those that we think identify as slightly higher income than we had originally tried to identify when we looked at our low to moderate income sample. Now, here's the results in just bar graph form. We find that households with solar are 46% less likely to receive a disconnection notice, 44% more likely to be able to pay their energy bill, 34% less likely to forego other necessary expenses, 21% less likely to keep their home at an uncomfortable temperature, and 15% less likely to reduce their energy consumption. Now, we also find that the benefits of solar spill over into other bills, specifically other energy bills. Here, first, we find that solar owners pay, or save rather, on average $65 per month as a result of having that solar. But we also find that it enhances their ability to pay for other forms of energy. Since most households don't just typically have just electricity, they might have electricity and gas, for example, or electricity and wood or propane. Now, here are the regression results. If you look at the solar line, you can see that if you have residential solar, it makes it the case that you are less commonly in a situation where you can't pay your gas bill, for example. And at the 10% significance threshold, we can see that it also helps households pay for wood and propane. I'll go ahead and stop there. No, I won't. My classes. I'm teaching a class, since we're allowed the liberty to do this, I'm teaching a class this fall on effective energy policy for the energy transition. And in the spring semesters, I teach a class on energy justice. Thank you.